Yeah. So today we're gonna talk a lot about the vocabulary of testing. So testing is, according to me, building and communicating knowledge. So we're building knowledge, we're gaining knowledge from a system by testing it, or we're gaining knowledge about the code by examining it. And we also need to communicate that knowledge to another part, like another programmer, or you need to communicate it to yourself, sort of. So perhaps you have a test result, you need to know that test result in the future. Or perhaps you create a system or use some automated system that creates a test result, and you need to have that communicated to you in a good way. There are multiple vocabularies for the same things. So people are calling the same things, but with different names, right? So the goal of today is to provide you a lot of definitions, and perhaps when looking at my slides earlier today, I saw that, oh my God, I'm using the wrong vocabulary. So this is not an easy thing, and hopefully we will discuss things enough to come to a conclusion of what kind of vocabulary we're going to use in this course. So let's start with what is testing and what is the goal of yes, there is a link on the course webpage on the lecture Basics of Testing. So I got a question if we can see these slides on the side somewhere. So the testing goal is to uncover errors. So the left-hand picture shows a video game. I actually don't remember the game anymore. Could it be like Age of Conan or something like that? But there's a man sitting in the air, floating above the air, and he should be sitting on a horse, right? So the current animation in this computer game is showing him sitting on a horse that is invisible, right? So in computer games, we're probably going to test these games. And probably we're going to have bugs like this one, right? This is a sort of funny bug, at least I think so. Because he's sitting in air and his shadow is projected and stuff like that, but we cannot see the horse. I've seen so many funny fail compilations on YouTube. I decided against showing it today. So the goal of testing is to uncover these errors, to find these, and hopefully to provide good grounds or good communication of these errors to someone who can test them, or fix them, I mean. If we don't find errors, if we don't find these problems, I would like to build confidence in my software. I would like to, if I'm going to release this game to a greater audience, I don't want them to laugh at me. If I'm smart, I will release these videos myself and I have a good laugh. But I want them to feel that I've given value for their money, right? So I want to have confidence in my software is doing what it should do. And that confidence will enable me to do good stuff with my code, like refactor my code, that is rewriting my code, perhaps. So we have another thing called verification that is sort of similar. If you want to put a multi-million-dollar rocket into the air, like this one, Ariane 5 rocket, you might want to make sure that it gets up there into space and does not explode, right? So the goal of verification is to show that there is no error for any input, right? So we check all inputs. We make exhaustive testing, or at least we do something that is almost similar to that. So there we want to prove correctness. Correctness means that we have implemented all the requirements and they give the correct output for each input. Yeah. So this is this French dude.
A final decision to go was
And
taken.
he's going to have the time of his life. I don't know how many of you have seen this video of Ariane 5. So they're going to launch this rocket. In 3, 2, 1, 0. And we have...
Allumage. Décollage.
Awesome. Fantastic. Everything is going as planned. Somewhere in this rocket there is a piece of software. And this piece of software will suddenly decide to make a 90-degree turn. So I actually don't remember the cause of that 90-degree turn. But it might be something with number conversions, but I may mix stuff up. Overflow. Okay, so it's, yeah, 90-degree turns are not a good thing to do in supersonic.
37
right?
seconds into the launch, the onboard computer
so if we
decided
have this
501
sort of
was 90 degrees off course.
money at stake, right? Or lives at stake. We want to prove correctness. We want to do verification of our software. So if we're doing something that is fun, oh, he looks really happy now, right? So horrible for him. Worst moment in his life, perhaps, I don't know. So shut the doors, yeah. Okay. So I've seen some bugs, and perhaps some of you have seen these pictures before. I sort of think this is funny. So here is a, this is sort of embarrassing. I'm so nerdy, you know. I like to build robots at home, so I buy these electronics components. There are some small microcontrollers, some of those. Perhaps some of you know something that's called Arduino, stuff like that. And this is a sort of smaller version of that. And they cost money, at least 19 Swedish kronas a piece. But I don't need to pay anything for those. That was a good bug, right? Yeah. And this bug, I sort of cannot understand how you can build a system that will produce such a bug. I think that this sum down there should be like computed every time this is updated, right? Every time you put an item in your basket, you should get an updated price. I produced this bug by having a saved shopping basket, because I tend to want to do the same kind of project again after they blow up, or I fry stuff like that, or something like that. So I had my my saved shopping basket called my own Arduino stuff that contained 19 items, and when I recalled that shopping basket, the price was not updated. So probably somewhere in this code, some programmer did an error or did a mistake or did not understand this situation. And they probably did not test it. If they had tested it, this bug would never be released, right? So of course I didn't buy this. I reported the bug instead. It's sort of interesting for me to see how they handle those kind of reports. You know, there's a Swedish phone company called Telia. A short while it was called Camellia. It was 99 or something like that. And I discovered their web page had been hacked. So I called them the customer service and told them, okay, your web page has been hacked. Not the ordinary page, the developer sites. So, and they just dropped the phone. So, and I was left alone. No thank you, no money, no nothing. But yeah, so people can react on problems. This is Google Chrome. So I'm watching the course web page for another course, and I sort of think it's funny that Google, with all its money, with its fancy testing processes, also produce these kinds of bugs. So the URL should not be in that horrible color, right? I guess that this bug never appeared in a Google Chrome developers on their computer, because if it did, they would fix it, right? I think that this bug might be due to me running Linux, and perhaps something in the operating system, because a program is not isolated. It's living in an environment, and that environment changes. So the input to that program and the way that program produces output depends on the operating system. Yeah. And this is all me. So this is a game that we released on Big Fish Games, I think. It's called Caribbean Pirate Quest. I've done some awesome voice acting in this game. Har! A lot of pirates, beautiful lady with a sharp sword and stuff like that. It's a puzzle game, you understood that, right? So this is the high score table. And of course, I test my software, but there are actually two bugs here. The first one is that the slider is on top of the numbers, right? It should be moved like perhaps 32 pixels to the left, so it does not cover these. But since I never tried this with like 100 high scores in my game, I just tried it for myself. So I probably got around 10 high scores or something like that, and then I killed the data folder and restarted the game, right? Because when I test my game, I need to like remove old data and old state, so that I don't start in an old state. I need to reproduce the same kind of movements in the game. So I need to create a new series of stuff. And I never did that for 100 times. So I never encountered this. So I probably only did this or checked that, okay, 1, 2, 3, they're sort of ordered in the correct order, and never bothered. So the other problem is with this slider that actually there is, yeah, thank you. Like there is the elevator. I don't know what's it called, elevator, that you can slide up and down and look at different places in this. So it's up there, but there are only 100 places. So we're in the bottom of the elevator. So, but actually there is like 500 results in this high score table. But I'm actually only showing the 100 top, but the slider shows that there are more, right? And I've never discovered that either, because I never had 500 high scores in my high score table. The problem here, and one thing that Google did solve, was that for me, I could not release a new version, because this was a downloadable game in the time when people were actually downloading executable Windows files into their computer and ran my unsafe code. That is a horrible thing. You should never do that. Nowadays, we have continuous integration systems. So when Google discovers that we have released a buggy version, they can update that version directly at their customers. And in this case, it was no easy way for me to fix this problem. So I had too little test data. Yeah, I had missing test cases and stuff like that. Embarrassing enough, I do introduce bugs into my software. And perhaps like that. Okay, this is the worst bug I've ever encountered. I spent 6 months trying to cut down this bastard. And this bug happened on one computer. Fortunately, I had that computer. It was a Windows system. You can see the blue screen. This is one of the reasons I don't like Windows anymore and only use Linux. So if you had a certain graphics driver on a certain graphics card that was shipped with, I think it was like 20% of all computers at that time. And that graphics driver was the driver that they shipped these computers with. And the drivers were not updated automatically. And our prime customers were not computer savvy. What's it called that? You know what I mean. They were not good at, they were not gonna upgrade their drivers. This bug was timer dependent, so it sort of happened only in certain conditions. You could not start the debugger and find this bug. So the conditions that the game ran in a debugger changed the timing, so the bug did not appear. I actually had to binary search my code. So commenting out stuff in a binary fashion. So first I comment out half of the game. And then I start the game and try to reproduce the bug, and it perhaps did not reproduce, or perhaps it did. And if I reproduced the bug, I could binary search that part of the code that I have left, right? But suddenly, the code did not, or the bug did not appear, and I didn't know if it was due to these timing issues or that I actually removed the part of the code that was in the bug. This bug did the horrible thing of producing blue screens, because games at that time was so close to the hardware. So we did like commands to the hardware through the operating system, but and you shouldn't really do that. You should have an operating system that you can blame and that could fix all the problems that you do. But if people get blue screens, they're gonna sue you. So this was a showstopper for our game, and we had spent like 19 iterations, 2-week iterations or something like that with the game, and we didn't want to throw in the towel and just scrap the game. We need to solve this. So actually, I found the bug and I understood the bug. I had a long discussion with Intel, who was producing this horrible graphics card and horrible drivers. And they didn't know this. 2 weeks after I found the bug and corrected it and was confident that the game worked, 2 weeks after that, an ID Software, do you know what that company? Yeah, they produce some good games, right? They released the Quake-free source code. So I was browsing through that code. Oh, Carmack. You know, the head of their programmers are called Carmack. And I was browsing that code, and they had the fix. 2 weeks after spending 6 months. And this was so, difficult to work with, because it was emotionally draining me as a programmer. So I didn't want to work on the project because it will blue screen on me. And I knew that if I release this, we will lose customers and perhaps get sued also, right? So bugs matter. Does not have to be stuff blowing up. It could be people feeling bad, right? Programmers feeling that perhaps their skills are not so awesome. That is bad enough. This is not my code. This is Tobias' code. And this is a game prototype. And you can see the soldiers running around, right? No, you can't, because they're lying down and running around in a lying down fashion. So they're face down, crawling, sniping, stuff like that. They shouldn't be. And we did not update the source code to make this happen. So the difference here was that time happened. Source code evolution otherwhere. The environment the source code lives in changes. The operating system changes. The drivers changes. The graphics card changes. Stuff like that. And in this case, the project was called Frontline. A subtle change in one of the components it relied on made all the characters lie on their side and running around, crawling instead of running around. Yes. This was not so long ago. I think it was your class in the classroom, right? So that you've seen these login systems. And to 2013 or 2014. I don't remember which it was. This bug only occurred on Sundays, and this was my example code for a solution for the assignment. So that is sort of embarrassing also, right? In this case, the day of the week, so slow, and introducing other stuff. Someone has a buggy implementation in this. Yeah. So here on the side, it should be like Sunday, first in Swedish. That would be the correct output, or the expected output. The reason for this bug was that in PHP, which this was written in, the API for creating these dates has two different characters that you can use to produce the day of week. And one of these characters expect a week number in the range of 0 to 6. And the other one expects the week number from 1 to 7. And they also differ on the day of week the week starts, right? Because you all know the week starts on Sundays, right? Not in Sweden, it doesn't. In Sweden, we start the week on Monday. That is the correct way, right? Or, so I was assuming things. And as you know, because some of you have taken my course before, assumptions is the mother of all fuck-ups, right? So I assumed the week started on a Monday. I assumed a Monday was like 1 or something like that, and perhaps I was using the wrong method. I didn't read the documentation carefully enough. I never tested my implementations on a Sunday because I don't work on Sundays. Yes, I do, but not in this course. You cannot assume that. If you're going to assume that I'm going to read on Slack on Sundays, you're wrong. Yeah. Actually, I let my students, or perhaps some of you guys, test this code also, and 60% said that, oh, this is okay test case, it works as it should. Some said that, okay, it should be like a comma here or something like that, or the time is not correct on the image of the test case or something like that. But there was only one person testing this on Sundays and found this bug and sent it to me. I'm very thankful for that. Sorry for the curse words. And it's still not closed. Okay. You're following me so far? Everything is crystal clear? So on the left-hand side, there is the original bug. That was actually an insect, right? And at that time, we had computers with relays. Do you know what a relay is? A relay is like a switch that you can control with a computer or with electricity. So either the switch is open or the switch is closed, right? If the switch is closed, it's transmitting electricity through that switch. So at that time, computers were constructed from mechanical switches. Today, it's transistors, right? Millions and billions of transistors, right? And we're making them smaller and smaller. But these were actually big enough for an insect to crawl in between and get smashed and then electrocuted, and then perhaps smashed and electrocuted again. But since the bug was, or the insect was in between these relays, it did not transmit any electricity, even if the switch was closed. So we had the original bug, right? So, and perhaps we will realize that we have a bug, or perhaps we don't. And if we see that the output is not what we expect, it's not okay, then we must ask ourselves the question, why? Is it a bug in my software? Is it a bug in the specification? We can have buggy specifications. So if you have a program and someone has written a specification for that program, perhaps you together with the customer, and you can write the wrong things, so the programmer will implement the wrong things, or you can think wrong. You actually are thinking wrong most of the time. Sorry, that was sort of evil. But we're actually doing that. So we're not thinking in optimal ways normally. So it could be a bug in the specification. It could be a bug in another software or hardware. In this case, it was a bug in the hardware, right? It was an insect. Yes. So we need to decide that, and we need to understand that our software runs in a system. It's part of an ecosystem of things, and we can put the blame in many different places. So our job as tester is to find the thing that we can fix, right? Sometimes we would like to find not only the thing that we should fix, but take the customer's side of the story. So here we have some idea. The blue guy, it's me. So I'm thinking of something, some requirements, some idea on how a program should work. So this is just represented by an orange rectangle and a green circle, right? And they're very precisely positioned. So I have this idea. I produce a specification from that idea. I specify that an orange rectangle with a width of 3 and a height of 2.5, and a green circle with a radius of 1.1 is drawn on top of that. I just write that. Sort of sloppy, right? And I give that to you guys. You're the green guy. And you think, okay, it's a green circle on top of an orange rectangle. No problem, the sizes are correct, but then you make some programming errors also, right? And then we have actually done like 2 types of mistakes here. We have an interpretation problem. And we have an, I can never say this word correctly, ambiguous. Is that the correct? Oh, I did it. An ambiguous requirement, right? So on top is not saying that it should be drawn exactly on the corner, with the center on the corner or whatever of that orange rectangle. And on top is that it should be on top of it and not over it, right? So exact wordings could be like a solution to this specification problem, that we misunderstand stuff. But we also make errors of programming. We introduce bugs. We don't fully understand the code. We work with imperfect information, both of the code and of the requirement, and therefore we introduce problems into the code. And then we test this. And the test perhaps is that, okay, if I input this and that, I should see an orange rectangle. And in this case, since I only test things around the orange rectangle, I will never find the problem. Right. Perhaps I test that the color is exactly the color of this rectangle that I imagined. So perhaps if the programmer shows just one RGB value from that, we will have a failing test. Perhaps that's good, perhaps that's bad. So, an error or mistake in thought or action. We actually had both, right, in the previous image. May lead to a fault in the software, defect. I actually call that bug also, sort of, but I don't know if that is sort of correct according to the book. But it may lead to an observed behavior. In the previous example, it did not lead to an observed behavior because I did not have a test on the green circle. So if we observe a correct behavior, we don't see anything, but this defect may lead to that. We have an observed behavior that is not correct, according to some specification. So I know that you've been listening to my voice for a while, and I know that my jokes are lame, but just one more slide, right? So we have some specification. This is the blue area, and it's actually into the green area also, right? And we have some implementation. That is the code that we've written, or actually the ecosystem also, right? Everything that works. And the green area is where we got it right. So we've seen something in the specification, and we have implemented exactly that. So every test case on that will succeed. But then we have stuff that did not succeed, and these are the faults. So there's stuff in the specification that was said in the specification, but we did not implement it. For certain inputs, they do not produce the expected output. You can see that there are areas outside of this. This is sort of a Venn diagram, right? And Venn diagrams are a bit, might burn the teacher. But let's think about stuff that is outside here. So we could have stuff that is not implemented yet. Perhaps we have downgraded the priority of that requirement. So it's in the specification, but we did not implement it. So that is called a fault of omission. So we did not implement it. It's omitted. We could also have stuff that programmers introduce into the program that is not part of our specification. And that is called surprises. So I know that some programmers are adding like small games into their programs. So if you click on this pixel, you can play asteroids. Stuff like that. When I create a bad enough assignment, programming assignment, some students will do that. And I know that at least some of the students here in the classroom got punished by another tutor, right? Because you were implementing stuff that was not in the specification. And when they saw this beautiful output, they didn't like it, right? Because it was not in the green area. It was out here. Or was that corrected? Yeah. Yeah. OK. So so I want you guys to think a bit of this picture. We're going to take a break for 10 minutes, I think. But just think of, OK, is this a correct image on why things go wrong? And yeah, just spend some time discussing this image. I think that could be a good idea. So we're going to take 10 minutes break. So 17 past 10, we're going to start up again. And ignition. OK, so we're back. And I got some questions on testing framework for the first assignment and stuff like that. So the default option is JUnit 4 and Mockito, the mocking frameworks of Mockito. I think it's called like JMockito now. But that is the default option. If you feel confident that you can do this in another language without needing help from the tutors, you're fine to use another language and testing framework. There are some study questions that might be a bit biased towards Mockito, like what is a test spy and what does it do? And then you might need to read up on Mockito in order to understand that so that you can answer that question during the explanation. So, but I don't want to stop you from like diving into the language of choice, right? Programming is, for me at least, a lot about passion and feeling that I want to do this and I want to test things and I want to try out something. I want to build a game. I want to investigate physics by colliding galaxies in a galaxy simulation and stuff like that. I want to put too many blocks in the way of you feeling inspired when you're doing programming, right? So I don't want to, and that is why the first assignment is constructed as it is. So the only thing that turns me down is students that say, what is the least I can do and get approved? That is the absolute worst thing you can say to me. But it's a perfectly correct question to ask do I need to investigate this area to get improved? It's the instructions are unclear in that or whatever. But so if you are working like with C# and another in your daily life, or that most of your courses are in C#, of course you should continue with C#, right? Because you have your skills there. And since we're going to do a bit awkward programming in test-driven development, and that's going to feel a bit awkward, you're probably going to need to have that confidence in the language. So please use JavaScript if that is your, what you imagine you to work with, right, in the future or somewhere, someplace, horrible place. Yeah, so will we focus on game testing? Not specifically. So for the same reasons, I don't want to put something in the way of you researching stuff. So there are, in all of the assignments, there are a bit of what is freedom, it's called, like in free, no, not in free beer, freedom as in Linux. As I want you to focus on stuff that interests you. Like in the second one, I think that you should investigate some kind of system and create a, yeah, how are they doing stuff. So do inspect a system that you feel interested in. So if your main interest is games, of course you should investigate testing in games. Perhaps I don't think that, I think it could be a good practice to do this first assignment as, okay, I want to implement the game and I want to do that with test-driven development, but it might be a bit difficult. But you're going to feel that difficulty in either way. So Python is fine, completely fine. Yeah. So the way I would like you to think of this project is to start really easy. Start with the simple to test things. Like start with a math library or something that produces output from input, right? So that you can create these very simple unit tests. Don't start with interaction or behavior and stuff like that. When you feel really confident in using the tools for this simple stuff, and you know how to write the simple unit tests for stuff like that, then you proceed to something with a little bit of like user interaction. Either user interaction through some user interface, through web, or through console. But then you need a mocking framework. And we're going to discuss this the next lecture more in depth on unit testing and stuff like that. And I want you to start this week, even if I have not set a deadline. So start with the simple stuff this week so that you're prepared for the next lecture. So I'm going to do a bit of coding on the next lecture. So it's probably a good thing to have at least checked and done a bit of coding yourself on testing and stuff like that. So what do you think of this image? When you think of your own projects, do you recognize this image in your own projects? No, you don't, because in your own projects, you have a specification that is like this. At least in most of your projects, right? So, and the implementation is like this. So you know that you have stuff that is left out here, right? You know that you have stuff I want. But you might not know that you have stuff that are surprises. And you might not know the total coverage here, because if you didn't have a successful testing strategy, you don't know what you have implemented and what works and what not. And my impression or my experience in students doing testing is that they only test the green area, and this false area, that is what I test as your their examiner. So sorry for that påhopp. Do you have an English word for påhopp? Attack. So, yeah. Do you agree? And this time I want you, all of you online, to raise your hands and practice raise your hands online. So do you agree? Awesome. 3 people. Only 3 of 40. 8, 10, 11. Can we get it up to 30? 19. 21, the good enough. Thank you very much. So, we had a program, some program, and we produce input and put that input into the program. And we said that we had some kind of expected output from that program. All the kind of input we can put into a program is called the input domain. Now it's sort of mathematical definitions almost, right? The set of all possible inputs to a program is known as the input domain. So if we have a program and it's called max, it takes an array of numbers and returns the highest number in that array. So the input domain of that is all arrays with all different combinations of numbers. Oh my God, that is one big input domain, right? If we have an input domain that is just like max, the same method, I'm actually going to write it. It returns a float. That is a number, right? And it takes float A. Now we ignore that array stuff, right? And it takes another float, B. So all values, all valid values of A and B, like A is 1 and B is 100. That is one value, right? So that is one input to this, one combination. But actually, we have a lot of combinations. If you have two floats, if they are 32-bit, you can you can multiply 32 bits with 32 bits and find out how large the input domain is, right? Because all combinations, A equals 0, B equals 0, is in this input domain. So all the stuff. Actually, the input domain is a bit bigger because we can have, in most cases, we have a program, right? So in this case, the program is max, just one function. But if the program is like dependent on other stuff like time, in the case of my bug, you remember the Sunday bug, right? The date or the time is actually input into this, right? So that is provided from the operating system into my program, and it becomes input. All the files, if you read a file, your hard drives all combinations, sort of, or all files that you could read, is your input domain into that program. So as you realize, when I talk about these multiplying 32-bit numbers together with each other, or having an array with 32-bit numbers, the input domain is huge. So do you remember the verification definition, sort of? What was that? Hang on, once more. All possible inputs should provide the correct output. That means that for just the max program, we need to test 32 bits times 32 bits combination in order to verify that. And it will take a while, right? Okay, so for most programs, the input domain is too big to exhaustively testing. And there are methods for working with that problem, but whatever. So correctness was the right hand, right? That was the verification goal. A program is considered correct if it behaves as expected on each element of its input domain. But since that input domains for most programs are so goddamn large, sorry for the cursing again, we need to settle for defining something else. Reliability. I said confidence earlier, right? So the confidence is sort of built up on the assumption that we can have a reliability score instead. So if we could produce random input, the reliability would be the chance or the probability of a successful execution. right? So if we have an input domain, let's use, and these are all the numbers. Let's start with a equals minus 241 or something like that. I don't know. And the same b is something else. And on the right-hand side, we have a up to 41 and b up to 31, something like that. There can be negative numbers, and the first bit is for deciding stuff like that. I don't know. It does not really 100% matter in this case. But so this is the range of all those numbers. So perhaps there are areas where we produce the wrong kind of output for that. Perhaps if we don't handle negative numbers, perhaps that is all the negative numbers. So in order to find out the reliability, we would randomize numbers from this input domain, perhaps this one, that one, that one, that one, that one, something like that. And then we would find a score on how many of these numbers that succeed compared to how many of these numbers that we have tried, right? So in this case, I have succeeded in these two and failed in those three. So this reliability will be 2/5 of this. So the probability of failure is, according to this measurement, 2/5. And this hurts you a bit, right? Because it's 50% of the numbers, right? So depending on how many test points we choose, we will get a different answer, right? So if I increase the number of test cases and they are, again, randomized, I will increase the reliability of the reliability. So normally, we do not test this way. We do not choose test cases on random. And we do not have expected output for all inputs. We don't know the output for most inputs. That is the normal case for programs. When programs are big enough, and someone mentioned games, and the reason I said that, maybe not games, was that in games, we have all these rules that we throw into the game, and the game can be in a gazillion number of states, and we have a gazillion number of inputs, and then it's really hard to know what's going to happen. Perhaps the guy should float above the ground and not have a horse. Perhaps that is the correct way of interpreting the game rules, right? If the horse has got an invisibility spell on it, at least. So again, we do some randomized input. What if the error is only there? We don't discover it, right? The other case is that if I decide what kind of test cases, I can do that with intelligence, right? So if I decide and I know that somewhere around here is a problematic area of the code, perhaps I should have a test case for that. So I create a test case there, and I create one on the side and one on there. That is probably, I have some kind of problem scent, a bug scent. You can smell your way to the bug, right? So good testers sort of feel this in their stomach. There's a bug somewhere, and I'm going to find it. And I feel that most cases, it's not that hard in student solutions. So yeah. So that was input domain, correctness, and reliability. And I know there are other definitions out there for these things. So these are the ones from the book, and I give them to you here so that you can see what kind of. Yes. So let's have a test case. So a test case is something, some instance of testing. So somewhere in the input domain, I choose one input. And then I know that for that input, I should get an expected output, what I expect. So if we have the pow function, oh, it's not so good, right? If we have the square function, right? I don't have another input, right? Yeah, that is the problem. The square function. First mistake. You should always test your slides before giving them. So I was probably thinking something else. So first of all, we have something that we want to test. In this case, it's called pow. Pow could be something else, right? In this case, the system under test is called pow. And I often write SUT in my tests. And that is why this is what's going to be tested. This is the method, this is the class, this is the instance, and this is the program that we are testing, the system under test. And we give it some input, some instance of that input domain. And I expect the output to be 9. And then we get an actual output. That is our observed behavior. It could be something else. It could be in a game that there is no horse. It should be a horse. That is the expected output. The input is that I step on my horse or whatever in the game, or I move the mouse to this pixel and I click it and stuff like that. Then we have some actual output. And in this case, we have, oh, it's sort of 9. I don't know. If we ask the computer to compare these numbers, it depends on the comparison function, right? If we're succeeding this test or not. But many cases, if we're working with floating point numbers, we sort of need to have a degree of correctness. Yes. So we need an oracle. The oracle is the one who decides what is correct according to the specification or not. And we can have human oracles. We can have machine oracles. This is the oracle from Delphi, right? Yeah. So does human and machine work as good as each other? Well, humans are pretty good at looking at that number we had before, 9.000001, and realize that, oh, okay, it's correct. Humans do that. Machines don't. It's not the same thing. I see a bit that is different here. It's sort of, when we compare these orange colors, right? Machine want to get an exact value, perhaps, and humans say that, oh, it's orange, I don't care. So let's see what the student said. So I asked the student to test one of my systems, and I gave them sort of what I thought was very detailed manual test cases. And these were like, OK, input this, input that, press this button, look at this image, compare that to what your output is. I don't only have the image. I also have a title called expected output. So this was not tested by a machine, tested by humans, students. And actually, on the left-hand side, you don't need to read the actual text. You can see these pie diagrams and see that even with that detailed instructions, students are human, and humans are interpreting these instructions differently. Or perhaps they are even seeing different things. So we can see that like 54 students says that it's correct, and 12 says that it's not. It could be that these students are so frustrated with my tasks that they don't just click. I don't care. I just click. I don't know. I have no idea. Or perhaps that they sort of fail in clicking. I missed the button. Or I missed reading one of the lines, stuff like that. Shit happens. But I also realized that actually my test cases were ambiguous. So the time of day, we've already said that on Sundays we had a bug. So no wonder not all students think that it's actually succeeding, because not all students are doing this the same day. It could be timing issues, like in my blue screen of death bug. It could be the environment. I'm using Internet Explorer 6. Awesome voice acting in that game. You really got to try it out. It could be the order of the test cases. Oh, but I logged in first. So, and then I went to this page and it does not show the input. So, no, it fails. And yeah. So if the order of the test cases, if the result depends on the order, we have some kind of order-dependent tests, and we need to run these in order. You will probably realize a thing or two about this when you're trying to do test-driven development. But in all cases, as I said, you want, in the case of my beautiful voice acting and the scrolling high score list, as I said there, I wanted to reset the state to make sure that my tests were not order dependent, that I always started in the same state, so that it will always come to the same results if I do the same thing. Reproducibility, stuff like that. That is good to reproduce bugs. So when I use the test result to solve my problem, I need to be able to reproduce it. Yeah. OK, and then we can have these ambiguous test cases just because of the language. Maybe I say click the button, and they try to use another thing, escape button, something like that. Students are not stupid. I love my students, but it's sort of funny. So I'm just joking. But you know what runs through your mind if you've written like really detailed test cases and people are just clicking away. And the test cases can be faulty. I make errors. As you will realize when you read my instructions, there will be language errors. There will be requirements that contradict each other. Thank you very much. There will be errors of omission, right? There will be errors that tests that are not according to the specification. So we cannot be testing machines. We must be intelligent testing human beings, trying to understand the requirements, trying to see what is the intent here, right? The testing machines, the clicking stuff, the boring stuff. If I'm testing the same goddamn game for the 120th time, and I really hate it, I'm not as good tester. I'm probably going to just follow the instructions. I'm not going to notice other problems. So testing is, and I hope you're going to, or I'm going to force you to read or watch a video after my lecture now. And this guy is really awesome at showing this to you. I hope so, at least. And he also says that all test courses in universities are crap. So it's a really good lecture. Well, so, OK. I think, do you need a break? Like, let's take 5 minutes. Like, stand up, do a bit of hand clapping and stuff like that. OK. We're going to start in like a minute. So regarding the book, again, I will try to make the course as book independent as possible. I think that it might be a good idea to catch that PDF. But if you're a book person and you can find the book and you want to read it, really good. If you just want to, like, okay, I just want to find out some certain stuff, some of these definitions and stuff like that, hopefully some of it is in the lectures. Some of it can be found in this PDF instead, or something like that. Yeah. There is no exam on the book that is book dependent, stuff like that. There are study questions for these assignments that are sort of taken from the book, like, yeah. Yes. So I also got the question, will there be any lab sections in Växjö? So there is no planned sessions at all in Växjö. That will be online. So there is actually no planned here on campus either. So there is online tutoring and examination time. So me and the two tutors, Joseph and Florian, will, depending on the number of students coming to this session, we will be 1 or 3 people. Yes? Yes, they are English speakers, yeah. Yeah. So, but I mean, you can always, like, I think that at least Joseph knows a bit of Swedish. So in written, at least, it says. So he might reply in English. Oh, yeah, in English, yes. And Florian, he knows German also, so I mean, then you're fine, right? So all tutoring session is online for all students. If there will be, like, okay, 80 students in queue and we have 3 tutors, if we see that, maybe we will change and add more sessions also. But I guess we also try to be responsive on Slack, right? So if you have a question, you can ask it in Slack, and perhaps you can answer each other's questions also a bit. Very much of the questions that I get are, I don't find this information, and I reply by, okay, it's on the course web on this position, right? That kind of questions are really good on Slack because other students can also help you find the kind of information or stuff like that. And I've not said it before, but we're going to use Slack for almost any question. So unless the question is personal, and with personal I mean, like, I have this disability, or I'm ill or something like that, and I cannot study, or whatever. That sort of questions should be emailed. All other questions should be asked in Slack. And since Slack, if we get what I want, that is a very active conversation on Slack, there might be cases where these questions get lost in the flow, and then you need to re-ask them, right? I want you to be active in this course, to be part of the course and produce content and produce solutions for each other, and yeah, stuff like that. Okay. So now we will talk about different levels of testing activities. So the first level is unit testing. So the definition of unit testing is that we're testing a unit. We're testing a method, a class, something isolated, something that probably just a method or a class. So the way of testing this could be automated, does not have to be automated. When you implement something and then you start your program and you try to find some output from that something, you're actually unit testing, right? So this process can be automated, perhaps by using a framework like JUnit or NUnit or stuff like that. Yeah. Unit testing we do when coding, right? So we're producing code, we're running the code, and we're testing it that way. We will have a very specified process of doing this called test-driven development that I'm going to speak about next lecture. Test-driven development and unit testing are separate things. You can do at least unit testing without doing test-driven development. So it's, yeah. OK, integration testing is when we put stuff together. So perhaps I'm testing this class, and this class is using another class. So that is an integration test. I test these two things together. You probably heard of continuous integration testing. And that is something that successful software companies are doing to produce code that is continually evolving and is continually released to customers. So they're constantly testing and putting stuff together and testing those things. But integration testing in the smallest part could be that I'm testing two classes together, or I'm testing one part of the system of 10 classes or something like that. That is integration testing. We could also have system testing. So this is a different phase and a bit bigger. Now I'm trying to test the entire program, the entire system. One system could be of many programs. So I put these programs together, or I test the program as a whole. I'm not trying to test one component. That would be like integration testing. But I'm testing the program as a whole. I put it together, and I do some system testing. Perhaps I let users test the system. So when I started my game, and I did not find the bug of the high score list, I was doing system testing. I was not testing a specific part of the code. I was running the entire program. OK, we could have sort of special cases of system testing. We could have a beta testing. That is sort of, in the game industry, a big deal still. But some companies are letting other people to test their software. But beta testing is actually, we're doing a release, and we let people test that specific release. Actually, in the gaming industry, most of these releases are so far away from the current working branch in their project, they are not actually used for finding bugs. They are just marketing. So beta testing has been something that was valid testing, but it's really gone away from that, at least in the gaming industry. There are probably a lot of industries where this is actually being used. So we have something, a release. We actually produce a specific output. Perhaps we let users install it, or we install it on a specific server for testing purposes, and we let people use it as if it was an actual application, as they were real users. Right? They're playing the game. They're trying to have fun. They're not, as in system testing, they're trying to find bugs. In beta testing, we're trying to do real stuff. Yes?
But often they can test like workload, server capacity, and stuff like that.
Workload, server capacity, and stuff like that. I would say that would be in system testing.
Okay.
It could. OK, let's say this. These terms go into each other, right? So a company can decide that, OK, I want to test workload of having 100 users instead of the 10 we have tried now. So we release it to 100 users for beta testing, but with the purpose of actually testing. Oh, sorry, don't find the ILITY word for that. Yeah, the load test. Yeah. Did I answer your question? Just interrupt you.
I just wanted to add that I believe some admin they like online multiplayer and stuff.
Yeah.
So I think they find it valuable to see a lot of players play at once to check that the servers are capable of these threats. But I'm not sure, perhaps that just...
Yeah, so there are probably companies still using beta testing as a testing process. I just heard the reference to using beta testing as just a way of gaining customers was from a Swedish company called DICE. So and the reason they could not really use the results was that they had branched away so far away from that release. Yes, so and there we actually got another thing that I shouldn't mention now. It's just going to confuse you. But if the delay between the test result and the actual code produced is too long, you will have a hard time to merge a test result or fix bugs. Okay, then we have another way of testing called acceptance testing. And this is where we have some kind of requirement that is a contract between you as a programmer producer and the one who has ordered that program. So this is the way of testing that we know that, okay, the program works as specified so that you will get paid. So there are many types of testing. So and they mix. And sometimes when I write my unit test, I'm actually writing integration tests because I cannot isolate this unit enough. So perhaps I'm doing that. And sometimes I actually are using unit testing framework to do system testing. I actually start the entire program, the server or whatever, and I actually do test the entire software and stuff like that. So it's just a sort of vocabulary, and there are mixing points and blurriness here. Yeah, sorry for not repeating the question. Sort of got lost here. Yes, I will try to repeat the questions asked in the classroom a bit better. Yes, and it's good of you to remind me because it's very easy to get lost in the flow of teaching. Okay. Now we're going to discuss some other expressions. Some of these expressions are quite useless. But it's testing vocabulary, and we need to know these things. So we're going to talk about black box testing, white box or glass box testing, model-based testing, user interface testing, smoke testing, and random text testing. And there are some weird images. So black box testing. So think of the system, the system under test as something that you don't know anything about. You only know that you can give it these inputs. The POW has 2 inputs, should have 2 inputs, right? Apparently mine has only 1. That is sort of a bug, right? But the black box is only showing you a interface, and with interface now I mean a programmatic interface, something that you can give inputs into. You could actually think of a program as that also. I can produce input with my mouse. I can click the button. I can put stuff in the input fields of this application and stuff like that. So that is the input, but I don't know anything about what's happening inside. And it produces some output. It could be a 3. I give it a 9. It could be a 3. In this case, it's square root. It has 1 input. Awesome, Daniel. We don't need to know how square root works on the inside. We only investigate this from the outside. It's sort of meaningless way of thinking, but sometimes it could be nice to know what a black box testing is. This is a typical thing that the first video will talk about. That vocabulary is good, but some stuff that is in university courses are not that useful, really. So, yeah. But if you have a specification, it might say that we don't know how the code works, but this is the kind of input you should be able, and this is the kind of input you should expect. So you can generate output from the specification without any knowledge of the code. Most of the time, we're actually doing this. We have a bit of code. You don't need to understand it. It's PHP, I think. It's probably horrible. But if we have knowledge of the code, as most of you taking this course will have, you're actually not doing black box testing. You're testing the system with knowledge of the code. That is glass box testing. So suddenly, the box is open, and we can see the code. And when we try to reach certain parts of the code, or since we have an if statement here, I need to create another test case. That is sort of the white box testing, or the and we can also test behavior this way. I know that if I send it this, it should do that. That kind of stuff. Again, it is not that useful as an expression. I'm doing white box testing at my work. It does not mean much. It's just an expression for something. But the interesting thing here is that we can generate test cases from source code. We can see that given this source code, not given the requirements only, given this source code, I can get an error if I do this. If I input these specific numbers, given this source code, I could get an error. The black box testing was more like, okay, with this requirement, I probably should look at negative numbers and positive numbers. That it works. In this case, okay, I have this if statement. I need to make sure that I get into that if statement. Yes. Or I need to increase my coverage. White box testing. We could have a mathematical model of the code. And here, if you want to somewhere say that Daniel does not know shit about testing, you should bring up this subject. So I don't know anything about this. I think I at least produced a video for you to read up on the subject. It's not something that we dive into, but if we want to do verification stuff, or we want to do more advanced testing, and if we have a problem that can be modeled, we can do model-based testing. So we create a mathematical model of the system, and then we derive tests from that model, and then we use those abstract tests they're called in this image. I'm just reading from the image, so I don't know more than you. I create actual executable tests to test the system. But look at that video, and you'll find out more. Perhaps someone want to investigate this and tell us about it in their third assignment, where you're supposed to choose something yourself. I also posted some Wikipedia link, I think, so that you can read up on the subject. I've never done model-based testing myself, so don't ask about it too much, right? Okay, user interface testing. This is a browser. In browsers, we can do stuff with our mouse. We can click, and we have buttons and stuff. And sort of when we have a user interface, new kind of test cases emerge from that. That was not in the interface. Oh, not in the requirements. They were not really easily to be seen in the code either. Suddenly we can have okay, if I copy from this text box and I paste it in this area, whatever, or if I press these buttons in this order or in that other order, stuff like that. So we can come up with test cases from just using the interface. It's not from the requirements that probably specify what's going to happen if you do stuff in the correct way. It's from the user interface, from the fact that we have all these buttons and menus and stuff. Yes, and it could be a very good idea. And there are tools for automating user interface testing. And I view the web, or an application that has a web user interface, that is a web page, is probably you're doing user interface testing when you're testing that web page. Yeah. It can be automated. You can have tools for that. It's not user. Yeah. Yes. Now I've actually grouped two subjects here that are not totally connected. But smoke testing, we're going to start with that. Think of it as this. You're trying to build a spaceship, right? You have this pipe of metal pipe. You have this hugely dangerous chemicals that are going to produce the lift for putting this into space or to your neighbor or whatever. And then you have these electronics and stuff like that. And then you put everything together. and then you run to your bunker, and then you turn on the switch, and then you see what happens. And you see if it flew into space, or if it just exploded, or if it's just smoke coming out of it. If it's smoke coming out of it, you do not approach that for like 24 hours, right? So the same kind of things you can do with programs. You just start the goddamn program, and you look, did it start or not? This is the sanity tests of testing. You're just, okay, I start the program, I see if did it crash, did it start, did it show the correct first page, whatever. So smoke testing can be that. You can do smoke testing with unit tests also. Okay, I just put stuff together, I start up the program, whatever, and I see that no exceptions are thrown. This becomes more effective. I don't know the difference between those two words. Becomes more effective if you introduce a lot of, let's call them exceptions for now. If you have error handling in your program and you actually handle problems. So if you get faulty input, perhaps you are throwing an exception. There is another way of doing this called asserts. But sort of dangerous telling you about this because we're going to talk a lot about the asserts next time, but in the test context. But you all know, hopefully, hopefully you know what an exception is. So if your program is throwing exceptions whenever something goes wrong, then you will probably see some smoke coming up when something is wrong, right? So I got the question from Niklas. Usually doesn't the compiler take most of the smoke testing issues? Yes, if you have a compiler, right? There are many languages that are not compiled, but yes, the compiler is, if you can use the compiler that way, that is a really good way of seeing if stuff holds together. That is the first defense, right? The compiler. Okay, random testing is a bit more organized or a bit more random. Oh, what? So random testing is a specific way of testing software. So we started up the software, and then we input random stuff into the software. It could be totally random stuff, or semi-random stuff, or intelligent random stuff. And then we see if it blows up. So it could be like this. You have produced this rocket. You're in your bunker. And then you shoot at the rocket with your gun from different angles, right? And you're trying to make it explode, sort of. You will only remember the bunker and the weapons and stuff. I know that, but totally worthless examples. But random testing could be, okay, if you have, let's say we have a compiler. Someone mentioned a compiler. We have a compiler. And, okay, the first thing that compiler should say is syntax error if you are giving it crap, right? So let's produce a text file by random. It should probably be, if you just create a random string, it should produce a syntax error, right? If it doesn't, you know that something is wrong. So we could use random testing to produce that string. And if you do a bit more intelligent random testing, you can actually produce source code by random, right? I have this random class name. I create a class, and then I create a random number of methods, perhaps 3,642. And then I create random code in these methods, and it could be actually compiling code, right? You could like just string concatenate stuff that looks like code, and then you will see if this runs, stuff like that. So random testing, and random testing has a benefit that we could like do it a lot, right? You can produce this input and you can test it. So it's more like, oh, the compiler withstanded our random testing for 2 hours, so we're more confident that it works. Yes. Yes.
Is random testing the same thing as fuzzing?
Sorry, fuzzy.
Fuzzing.
Don't know.
Okay.
Sorry. Could be. No idea. So your home lecture for the next assignment, for the next lecture, is to find out what fuzzing is, if you want to. So random testing is very interesting. I've seen a Udacity course. You should not give, yes, you should give hints for people to take courses on other universities. There is a Udacity online course on random testing. It's actually called like testing, but the guy who's giving the course is more passionate about random testing. So at least half of the course is about random testing. So it's really, really funny to see how they produce this input and stuff like that. So if you're going to investigate random testing, please do that. We've also, me and a previous student, used some random testing to see if we could find good test input automatically. But that is another story. OK. Yes, so what could we test? We've talked about, so I'm working in an environment that is not perfect, right? No, no, no. So the problem here is that we have different states, right? So I've used this program for a couple of hours now. Everyone is getting a bit tired. I know. But so suddenly the smartboard does not work after using it a while. So it's probably a bug, but we're going to stick to this one. So we've tested reliability, or we know what reliability is. And there are a lot of other illities. You also know what correctness was. That was when everything worked for any input, right? But we could also have other kind of qualities that we want to test. You want to test that every requirement is in there. That is a test of completeness, like. So if everything in the specification is in the program, sort of deciding if the green, blue, and yellow boxes are more or less over each other or not. Yeah, you could test other things like consistency. Does every button have the same look? Does every input check for validate the input or something like that, or stuff like that? You could have usability testing. You could have like performance testing. Now we're getting really fuzzy here around here. So most of the time, in this course at least, we're going to focus on reliability testing, and perhaps a bit on completeness also. We want to know what we have tested, and we want to show that to other people so that we convince them that we are doing a good job as testers. There are different qualities also. Awesome. When I get a bit tired, I kind of mix Swedish and English. So the dynamic qualities are tested when the program is run. And this, again, is a bit fuzzy definition, because stuff can sometimes be tested even if the program is not run, like completeness. If I want to know if every method is actually tested, I can see if there is a call from that method from the test suite, stuff like that. But dynamic qualities are when we run the program. Static qualities are stuff that we can analyze and find out when the program is not run, like if the code compiles. Yeah, just some definitions. So in the future, you're gonna write a test plan, a test strategy, a test plan. And if we have different qualities, and you know that the input domain is really large for most programs, right? So you have to decide what kind of strategy you're going to use to achieve some kind of goal. And you're going to communicate that either to to your customer, I have tested this program as best as I could, since you can see here I have tested this. Or to a tester, I want you to test this program this way. Or to a group of developers that are working together, this is the test strategy we're going to use. This is the software you're going to install. This is the requirements we're going to focus on in this iteration and stuff like that. So a test plan tries to communicate that to someone. It becomes much more concrete when you have someone to communicate to. And I want the test plans that you write in this course to communicate to other students and to your examiner. Stuff that's going to be tested, right? So stuff that could be in a test plan is what qualities are we focusing on? Like, okay, in this test plan, we're focusing on reliability of the system. We also want to make sure that the system is usable, and we want to make sure that it does work under heavy load. So we take free qualities and we test those. It could say what we're going to test, like, okay, we're going to test the user interface here, or we're going to test the code using unit tests or stuff like that. How we're going to test, okay, we're going to use unit tests for automated unit tests. We're going to use Selenium for recording test cases through the user interface. We're going to present the results as reliability measures, whatever. Graphs, lists of stuff. Yeah, lists of test results, perhaps. Depends on who's going to receive this, right? If it's a programmer that's going to receive it, he wants a test report so that he can start to work on those bugs, right? Or the bugs of omission. That, okay, I forgot to implement that people are going to be able to log in, whatever. Yeah, if it's the customer, maybe you need to show him that, okay, the reliability of this software is currently at 99%, something like that, or yeah. And perhaps you should also specify what you should do with a failure. And how do we know that we did good or not? So the test plan and the requirements should guide the testing effort that we're doing, that we're going to do. So from these documents, we're going to create test cases. So in assignment 2, you're going to use some system or some write a test plan and also write test cases from that test plan and the requirements, and perhaps from the source code also. Yeah. And then when we receive results from these tests, when we get results, we must have something that, okay, how are we going to handle these results? What are we going to do? And perhaps these should be in the form of strategies for continued development. So if we see that, okay, we're unable to regress, we're unable to retest stuff that we already tested. After change, we retest stuff, we regress, regression test. Maybe we need to have more unit tests, or we need to, if we think that the manual testing takes too long, we need to automate our testing process. If we feel that, stuff like that. It could also be that, okay, we're finding a lot of defects that would be very easy to find if someone checked each other's code. Right? So perhaps we need to introduce a code check before committing or something like that, or before a push request is handled. Yes. I know everyone is tired, or at least I'm tired now. So I think this is sort of the last slide, or something like that. Hope it. Oh, maybe I have more. Testing as I've said before, okay, we get a test result, and that is sort of the starting point of a change. So someone is going to use that test result in order to change the software to the better. So when debugging or as a programmer, I use tests a lot to find out information, to ask questions to the code. If you've been programming PHP, you know that you don't have a compiler. The PHP scripts are not run until you run them. And most of the PHP programmers out there produce really crappy code. So you need to be really good at debugging if you're going to live in this environment. And in order to do this debugging, you need to find out how does the system work. And you need to ask questions to the system. And you can actually ask questions by testing, right? So you can write small tests, or you can run the code, or you can introduce code into the code that extracts information like var dump or echo stuff out of the code, and you run it. Yeah. So when we have some kind of bug, some kind of problem, we find out information about the problem using testing. It could be a good thing if we can reproduce the testing that was done before that identified that there was a problem at all. So if you check debug databases, bug databases, sorry. It's very common that in a bug database, they want to have a way of reproducing the bug, right? So they want to have, first you're going to press the start button, and then you press the other button, and then you like that. And then you get a bug, and you identify the bug. So you need to find out that. And then you change the system, and then you do regression testing. So change the system, and then you do regression testing. So regression testing means that we retest and make sure that the bug did not, that the bug did disappear, and that we did not introduce new bugs. Yes. So so the lecture is over. Yay! Now it's time for you guys to work. So what I want you to do is look at James Bach open lecture on testing. It's awesome, some part of it. It's crap, some part of it. It's like, I think it's very long. So you might want to have like speed up the sound after a while. And you might want to eat something during, or sit as a group and listen to it and stuff like that. He's very krass. And very mean towards universities like me. So it's sort of fun. But you don't need to accept everything he says. I want you to criticize. I want you to criticize my words and his words and everyone else's opinions on stuff, right? You're going to be programmers, and you need to be selecting the kind of information you want to see as truth, right? So remember this when you watch all the videos I've posted. Yes. So that was James Bach. And there's another video. And both of these videos are pretty old and not best quality and stuff like that. But when watching the second video, I really love her. She's from Google. She's amazing. And the thing that I love about this video, and what I want to give you there, is both a little bit on agile testing, but the other way, the passion that she feels for testing, the why she feels that, and also a little bit of history on the history, the place she has been, right, and the way that they are or did projects in 2007 in Google, right. So watch that video. It's an hour, something like that. And then the third thing I want you to do until next week is to install an editor, install a testing framework, perhaps a mocking framework, do a bit of programming, do a bit of testing. Does not have to be test-driven development. Just use JUnit or use any unit tests framework. Write a bit of code, read the first assignment so you can ask questions on it. Yes. So I'm going to see if someone has written any questions. Any questions? On Thursday there is tutoring time, yes. So it's online and it's for everyone. So if you run into trouble installing stuff, perhaps you can say hello to us during tutoring time, yes, on Thursday. Otherwise, I want you to register for Slack and make sure that you have access to Slack. Was this okay, this lecture?
Yes.
Yeah, okay. A little applaud for me and for everyone who dared to listen to my... Thank you very much.